Hello everybody, so this is Mr. Bowman. Today we're going to be looking at complex equations and special solutions. So what I mean by complex equations, just in case anyone made it to this video by accident, this is not the mathematical definition of complex, which we are not going to cover yet. This is just equations that are trickier than normal. So just to clear that up before we get any further. All right. So complex equations, as opposed to the 1, 2, 3-step equations we've been looking at before, what if we see something that looks like this? 3x minus 2 times the quantity x plus 3 equals 5 minus 2x. Okay, a lot of stuff going on here. So whenever we see something with this much stuff going on, what's good to keep in mind is we want to try and clean up each side before we start moving things around. So on this right side, I don't have anything I can clean up. They're both different terms. I have a constant and an x term here. Over on this side, though, I got some parentheses and various things I can deal with. So I'm going to try and do that first and see what I can do. So I can't do anything on the right, so I'm just going to bring that down. But I can distribute that -2 into here, and be very careful with this negative sign. So my suggestion is actually to make this a plus a -2, and it's going to make your life a little bit easier. Okay. So this 3x I can't do anything with, so it's going to stay there. Plus -2 times x is -2x, and then plus -2 times 3, which is -6. And I'm going to leave those in parentheses just because they do have negative signs, so it's going to help me clean things up here in a second. All right. So 3x plus -2x are now like terms. So now that that distribution's out of the way, I can deal with that. 3x plus 2x is x, and then I don't have anything to do here, so you can leave it as plus -6 if you want, but it's usually easier to make it -6 just so you don't have quite as much in the way of extra notation. All right, and then still nothing going on over here. Now, this side's a little more simplified, and I have back to my variables on both sides of the equations example we've looked at previously. So the first thing I want to do is get all the variables to one side. I know some people have told me that they've been informed they want to always move the variable to the left side. That's a good practice to get started if you're not sure what to do, but it doesn't really matter. But we'll go ahead and do that since I've had a couple people comment on that. So I'm going to add 2x to both sides so that I can, because this is a -2x, and -2x plus 2x is 0. Over here, I have 3x. Can't do anything with that 6 because it's not a like term. Down there. Back to my normal equations. How do I get rid of subtracting 6? Opposite operation is addition, so I'm going to add 6 to both sides so that this turns into 0. 3x equals 11. So this one's not going to be nice, but that's okay. Fractions are our friends. So this cancels out when I divide by 3 to deal with that multiplication, and this just stays 11 over 3. It doesn't come out nicely. If you try and type it in a calculator, you're going to get a repeating decimal. I would be fine with that too, as long as you can write that appropriately. But usually it's easiest if you already have it written as 11 over 3 because you divided by 3. Just leave it 11 over 3 and don't worry about it. Okay. So when we're talking about complex equations in this video, that's what we're talking about. There's more steps, more stuff going on, and really you just have to make sure you slow down and do it step by step. Okay. I do want to clarify one thing, just so we don't have any confusion. Previously, I said when solving, you want to use your order of operations backwards. That only applies when we start doing this part, where we start adding things or subtracting, multiplying, dividing to both sides. When I'm just cleaning up a single side, that's a normal expression. Oops, sorry, my shadow's in the way. That's a normal expression, so it works like normal. So I start with those parentheses, then I would do any other multiplication, division, addition, subtraction. So when you do it, start doing the process backwards is only when you're doing it to both sides of the equation. All right, and then we do have a couple special solutions. These are confusing, but honestly easier because there's less, how do I say this? There's less possible answers. When you have a number, there's an infinite number of answers. There's only 2 special solutions. So, little less to keep track of there. They're going to look like normal. So, maybe you'll have something like 2x minus 1 equals 2x plus 5. It's going to look like a normal equation. But when you try and get all your variables on the same side, so these are both, let's go this way, positive 2x, so I need to subtract to cancel that out, because I remember I do whatever would give me a 0 when I put them together. So this is 0. I have negative 1. This one's also 0, and I get a 5. That's the important part that tells you you're going to have a special solution. Both variables drop out at the same time. Now, this is a relatively uncommon scenario unless someone specifically makes an equation try to do that. So if you do see this, always go back and check your math. Obviously, this is a single step. It's really easy to check and see that we did that correctly. But when you get to this point and there are no variables, there's only 2 possible situations. Either it's false or it's true. Okay? So what you're looking at here, negative 1 equals 5 is definitely false. Those are not the same number. So what you would write is no solution. And that would be your answer. Okay? You don't need to give me the negative 1 equals 5. That is part of your work, but the answer is no solution. Okay? Because there's no possible number you can plug in for x to make this true, because the x's are going to drop out. On the other hand, if you come down and get something like, and this is just the last step, 7 equals 7, that is definitely true, right? It's equal to itself. In that case, you would write all real numbers, okay? And that would be your answer, which means no matter what number I plug in for x, 7's always going to equal 7. So this is kind of your trigger of special solutions. If there are no variables, stop what you're doing, see if it's true or false. If it's false, it's no solution. If it's true, it's all real numbers.